Today, we will learn about statistics, universe, sample, and random and non-random sampling techniques. Now, in this module, we will essentially learn about the brief history of statistics, its concept, the concept of universe and sample, and we will also learn about various sampling techniques. Historically, statistics is the result of fusion of two original disciplines. One, primarily descriptive in nature, which is concerned with collection of data, and the other, essentially analytic, with the concept of chance and probability. From time immemorial, men must have been compiling information on peace and war. Statistics is, in this sense, is as old as a statecraft. At each upsurge of social and political development during war, there is a rapid growth and expansion of statistical practice. In India, evidence of use of statistics in running state affairs comes from Arthasastra of Kautilya way back in 3rd century BC during the Maurya period. In another peak period of Indian history, at the time of great Akbar, we find a description of highly developed statistical system in Ain-e-Akbari, which is practically the administration report and statistical returns of the government of great Akbar as it was in 1590 AD. Etymologists may find root of the word statistics in the Italian word state, and a statista would thus be a man who had to do with the affairs with the state. Thus, statistics consequently mean a collection of facts which might be of interest to the statesman, whether they were given in the form of numerical observation or not. Now, let us learn about the concept of statistics. You see, statistics is a method of dealing with data. This definition recognizes that statistics is a tool to collect, analyze, and interpret mainly numerical facts or observation, which can be collected from a population or from a sample. Now, drawing a sample is a scientific process, and this involves certain statistical techniques so that the sample represents the population without any bias. The raw data that are collected from a population or from a sample, if numerical in nature, needs to be processed or analyzed logically in order to present the information in a convenient, usable, and understandable form by displaying them in tables or figures so as to illustrate the main features. This can be termed as descriptive statistics since we are describing the data. The interpretation of analyzed data again requires certain statistical tests or analysis so that an inference on the data can be drawn with some certainty. This can be termed as inferential statistics. Now let us know why statistics in anthropology. You see, field work is an essential component of anthropology. And for the purpose of field work, anthropologists visit places like a village or town or a region or a community and collect various biological and socioeconomic information. Biological information may be on height, weight, hemoglobin level, head length. Socioeconomic information may include occupational types, education, and so on. All these information are numerical in nature. Thus, statistics become an essential tool to organize, analyze, and interpret this huge body of numerical data in a meaningful way. Now, when statistics is applied to biological data, it is called biostatistics. For example, you collect height, weight, population composition, age, sex structure, etc. All these are biological information, and when statistics is applied to it, it is called biostatistics. Now, let us come to the concept of universe and sample. First, I will start with universe. You see, the concept of universe and sample depends on the problem to be researched. We look at relevant literature to see what information is available to us. And on the basis of this knowledge, we hypothesize certain things which are to be tested. In the subsequent stages, we decide on the groups. For example, the community or the organization, the family, the individuals, from where data are to be collected so that our study objectives are met. Suppose if the purpose of our study is to find out the frequency of adolescent girls who have attained menarche in a community or a village, then all the adolescent girls of that community or of that village has to be investigated. Thus, all these adolescent girls of that community will be my universe. The word population is used alternatively with universe. In brief, population or universe means the totality of the individual about which inferences are to be made. In other words, all the members of the target group which we intend to study may be called as universe. One might also be interested to carry out a study on infants of a district. In this case, all the infants of that district will come under the purview of our study and hence the universe. Or my universe may be all the working mothers with children below 5 years of age, if they constitute my target group of study. Thus, let us find out a definition of universe. A universe can be defined as the collection of all individuals, families, groups, or communities about whom we are interested to study. In statistics, universe is represented by a symbol, capital N, and the estimate that we derive from a population is called parameter and is symbolized by mu. Each member of this universe is called an element of that universe. With reference to my earlier example, we can say that each of the working mothers who have a child below 5 years of age are the elements of the study. Or all the adolescent girls whose age at menarche we wish to find out are the elements of our study. Now, let us come to the concept of sample. Sometimes, universe tends to be very large, and for this reason, researchers rarely study every element of the universe. Rather, they select a portion of the study universe. But the selection of a portion should be free from any bias so that it can be projected as a representation of the universe. Thus, let us try to find out a definition of sample. A sample may be defined as an actual representative of the universe. Now, you might inquire, why use of sample, or why use a sample? Well, it is desirable for any research to study each and every element or unit of the study population so as to get an appropriate estimate of the universe or of the whole study population. But practically, it is very difficult to study every element in the population. You see, problems like unavailability of the fund. Suppose you are doing research and your fund is limited and you have to complete the research project within a short period of time. So, time constraint, fund constraint, non-availability of the study participants, and lack of manpower compels a researcher to choose a representation or a sample from his or her universe of study. Thus, a researcher resolves this problem by studying a sample and generalizing his or her findings from the sample to the population. This is the most efficient way to do research, since we have methods that allow us to estimate the characteristics of a population or universe by measuring a sample. However, one must keep in mind that if the sample fails to represent the population or the universe, then the estimate derived from the sample will not be the estimate of the population. Now, let us come to the topic of sample size. That means how big a sample should be. In statistics, sample is symbolized as small n. Unlike population, which I told earlier, it's a capital N. In general, it is understood that larger a sample, better is the estimate. Now, the composition of samples may vary in size, in quality, and in the technique of drawing the sample. The size of the sample also varies with respect to certain criteria. For example, the size of the population, the level of reliability required in sampling. Third, the cost of sampling, how much fund is available to you. Fourth, the variability in the population. I will explain all these points. For example, if the universe is large, the sample size should be large. Or if one wants to have a reliable estimate of a parameter, parameter means population estimate, the sample estimate should not yield high error of estimation. A little fund will not help to draw a large sample because you have small fund and you have to rely or bank on a small sample size. Now, if the universe is heterogeneous, that is, if the variability in the population is high, the sample size should be such that the chance of representation of each element becomes high. So this is very important, Now, let me give an example. If you go to a fair price shop, that is a ration shop, you will find that for the customers, small amount of rice pulses are kept in small containers. It is understood that the bag that contains rice is homogeneous and the shopkeeper took a small sample of that rice or pulse in the container so that the customer can check the quality of the goods that they are going to purchase. So here it is considered that the pulses or the rices kept in the bag are homogeneous in nature. So the small samples are kept for the customers to check about the quality. Next, let us come to sampling. One of the most important requirements in any database research study is getting a representative of a study population, which might provide trustworthy estimate of the actual population. The process of getting a representative population from a universe is called sampling. Now, there are two major types of sampling techniques. One, simple random sampling or probability sampling, and non-random sampling or non-probability sampling. We will first start with random sampling. Random sampling is a procedure of drawing a sample from a population so that each and every element in the population has an equal chance or probability of being selected for the sample. Let us start with simple random sampling. This is the most basic type of sampling, and in many cases, this is the most desirable one. In this type of sampling, every possible element has the chance of being selected, and it is also considered to be a reasonable sampling pan for sampling homogeneous or heterogeneous population that do not have distinct subpopulations that are of interest of a researcher. The sample may be drawn unit by unit, either by numbering the units such as persons, families or households of a particular population from published tables of random numbers, or by lottery. The second is the stratified random sampling. In a stratified random sampling, the population is divided into well-defined, non-overlapping subpopulations or strata by population characteristics like ethnicity, income, age group, and marital status, and so on. Here, a simple random sampling will not be helpful because, you see, this process will not guarantee that each subpopulation is sufficiently represented in a sample. Thus, a simple random sample is drawn for each subgroup or substratum. The following are the steps that should be followed in stratified random sampling procedure. First, identify the strata of the targeted population. Do it first. Second, develop a good sampling frame for each stratum. Third, determine the overall sampling size or sample size and the strata sample sizes. And lastly, select a simple random sample from each stratum. Now, systematic random sampling. You see, systematic sampling is a random sampling technique which is frequently chosen by researchers for its simplicity and its periodic quality. This is a random sampling with a system. From the sampling frame, a starting point is chosen at random, and thereafter at regular intervals samples are drawn. For example, suppose you want a sample of 8 houses from a street of 120 houses. Now, if you divide 120 by 8, the value that you will get is 15. So every 15th house is chosen after a random starting point between 1 and 15. Now, if the random starting point is 11, Then the houses selected are 11, 26, 41, 56, 71, 86, 101 and 116. In this way, you can choose 8 households from that street. Now, let us come to cluster sampling. This is another type of random sampling technique where you are choosing clusters at random. A cluster may be a village, maybe a school, ward, or a slum population. Now, at each level, the units and subunits are randomly selected, and thereafter the enumeration of all the representations of the subjects in the cluster is carried out. Next is multi-stage sampling. Now, when sampling procedure is carried out at several stages using random sampling, it is called multi-stage sampling. Usually, in large-scale surveys like census operations, this technique of sampling is of great use. For example, you can select 3 states from a country randomly, then 4 districts from each state, again 5 to 6 blocks from each district, and maybe 10 villages from each block. And the data you derive from this process of sampling can give a good estimate of the population in a short time and with less fund. Now we will shift to non-random sampling. Now, non-random sampling does not involve random selection of elements of the universe. But it does not mean that the samples are not the representatives of the universe. However, in applied social research, there may be circumstances where it is not feasible, practical, or theoretically sensible to do random sampling. And here we consider a wide range of non-random sampling techniques, and one of them is accidental sampling. And this is probably the weakest form of sampling. In this procedure, the participants are recruited as they are available or happen to be convenient to the researcher. For example, we often see the interviews that are carried out in electronic media, that is the television, seeking opinion from general people after declaration of budget or after a major political incident. In this way, we try to get a quick feedback, but certainly from a non-representative group. Next is quota sampling. Now, this sampling attempts to avoid some of the biases of accidental sampling. Here, the researchers have some knowledge about the characteristics of the population likely to affect the dependent variables. For example, the age, sex, and ethnic groups. That means here the samples are chosen from the different categories. For example, from different age groups, from different sex, and also from different ethnic groups. Suppose, let me give an example. Suppose you want to know the perception of people towards the use of a particular contraceptive method. The use of a particular contraception method is a health behavior, and this is a dependent variable which may be differentially liked by people of various age, sex, and ethnic groups. Now, next one is purposive sampling. Purposive sampling is also known as judgmental, selective, or subjective sampling, and this is also a non-probability sampling technique. This is possible if some characteristics of the population are known a priori as a result of some previous service or many other things. Now, let us think of a case of focus group discussion. In focus group discussion, the participants are recruited on the basis of certain purpose. For example, an investigator wants to find out the attitude of mothers towards visiting hospital regarding child delivery. In such a case, the investigator will choose participants from young mothers, older mothers, midwife, and the representatives from the hospitals. In this way, the actors who are directly involved are inducted for the purpose of study, and hence no randomness is there in selection. The last is snowball sampling. In snowball sampling, you begin by identifying someone who meets the criteria for inclusion in your study. You then ask them to recommend others whom they may know and also meet the criteria. Although this method would hardly lead to the representative samples, there are times when it may be the best method available. Snowball sampling is essentially or especially useful when you are trying to reach populations that are inaccessible or hard to find. For instance, if you are studying the gay or lesbian communities, you will not find a good list of these people within a specific geographical area. So, in this module, we learned about the concept of statistics, a brief historical backdrop of statistics, the concept of universe, sample, the utility of sampling, the various sampling types, and its merits and demerits.